The volume's not on. Turn the volume.
Hey everyone, how are y'all? You can, if you don't feel comfortable talking on the microphone, you can text me questions. I just can't always see it because I have to toggle back and forth between the worksheet and the Google screen. So if currently I have the classifying real numbers coloring activity up, but if you have questions that are on any of the others, I can help you with that. I was working on this earlier. The downside to this one is I don't have an orange color, so I have to use red when I'm working on that. But I know we had a few other worksheets that we were working on. So what are your questions?
Mostly about the coloring one, classifying real numbers one.
The classifying or the ordering?
Classifying real numbers.
Okay, so the one that I had up. Good. All right.
Yeah, that one.
Can you see it okay?
Yes.
Okay.
And if you're confused, my birds are in the background making all that noise. So.
Oh, okay. Well, I can barely hear them.
Okay.
You'll hear in my house, you'll hear my dogs. So, you know, I'm okay with birds if you're okay with dogs.
Yeah. They were just kind of loud last year, and they're still here. So.
Oh, okay. Oh, well, that'll be entertaining. I like it. I like it when Math Lab is lively. So every now and then, if, hey, you guys are on there, if you see that someone has texted me a question, would you guys give me a heads up?
Yes, ma'am.
Okay, thank you very much. All right, so in classifying real numbers, let's take it one box at a time, and then we'll color as we go. So let's start with
it's off too.
This one right here. Negative 24 over 12. The first thing that you want to do is get it in its simplest form. So that's basically a fraction is a division problem. So if I have negative 24 and I divide it by 2, the end result is going to be negative 12. And I'm hearing feedback on one of them, on somebody. So anyway, so negative 12. All right. Referring back to the Venn diagram that's in your book, negative 12 is an integer, which also means it's a whole number. So when you're looking at a Venn diagram, the smaller that it goes, like a whole number is an integer, is a rational number, is a real number. So you kind of work your way out. But a rational number wouldn't necessarily be a whole number. So it's kind of like, you know, like when you think of geometry, you've probably heard the expression before that a square is a rectangle, but not every rectangle is a square. It's kind of along those same principles. So negative 12 is an integer. And so because it's an integer, it's also a rational number and a real number. So I would color that one purple.
I put it yellow, and then I realized that it was also a mixture once I reduced it. So I went back.
Oh, I got you.
Now it's brown.
That, and I do understand that. And one of the things that you want to make sure, because when you would first look at it, I can see where you would think that because it's expressed in a fraction.
Yeah.
Which just is a clarification in the fact that every rational number, so that means every integer, every whole number, every natural number can be expressed as a fraction. But what we want to do on each one of these individual numbers or these boxes is to ensure that you have it in its fully reduced form and then classify it.
And we were saying that 0 didn't count as a natural number. But it's just...
It does not count as a natural number, but it is a whole number.
Okay.
So,
It'll be blue.
so that would mean it would be colored. All of the zeros, which there's one that is expressed just as 0 by itself. So because we're on that particular one, those are going to be the ones that are colored blue because it's not a natural number. It's just a whole number. So let's take a look at that. This one then would be colored blue. This one, 0.0, is still 0 once you get it in its simplest form. So this one would be colored blue. And then this 0/7 would be colored blue. I think those are all the zeros on. Nope, look, this guy down here. I didn't see him. So he also would be colored blue. Good questions.
I have a question.
Okay. What's your question? Anybody else have a question? Or you want me to just keep working? Oh, is somebody typing? I hear typing.
Okay, did you see it or should I read it to you?
Oh, yes, I see. The sheets, the coloring sheets, all of these sheets. Let me see. I think I have this pulled up yet. Hold on. I'm creating an assignment sheet and I will start sharing it on Google Classroom. Let me see. Let me pull it up. And this will kind of help you keep track of what is going to be due. And I will post this on Google Classroom. But this gives you an idea of what is due so far. So it would be 2.1 practice B. Make sure that you're showing your work on numbers 13 through 20. And then the worksheets covering 2.1 and 2.2. The worksheets from the class, the ordering real numbers worksheet, the classifying real numbers worksheet, and the one-step equation maze and riddle page, both the front and back. Those are going to be due on test days, on test day. And then we're going to have 2.2 and 2.3 worksheets for class. They are actually due on the test day, not quiz day, which is next Wednesday, but actually the test that will be coming up in a couple weeks. And I will post that on Google Classroom so you can kind of keep up with what is. So one of the other questions that was asked is, do they necessarily have to be done today? One of the interesting things about a university school is that you can, like if you're mowed under in one class and you can't get to something today, you don't have to do it. But be cautious because you don't know what tomorrow brings. So if you have, what I would try to do, what I recommend is that you try to work on math for about an hour on your Tuesdays and Thursdays. That would be my recommendation. Hour and a half is what you should spend in math.
I'm so sorry about the random.
Miss Sparks?
Yes. I'm sorry?
So for the real and irrational numbers and stuff like that,
Yes, sir.
should I just rewatch the video? Because I'm not really getting that.
Oh, if we can actually go over the worksheets, if that will help. because that's
Yeah,
really
the only
what I would be
the
more
only
than happy to do that. Do you want to go over the classifying, continue
right.
the classifying, or do you want to go to ordering?
The classifying real numbers would be good.
Okay. All right. Well, let's start. Let's keep working through that. So on the worksheet, can you see the worksheet? Okay.
Yes, ma'am.
Okay, good. So let's look at the number 1/2. Do you see, everybody see where that is? It's the triangle that's underneath the purple square that I squiggled in. 1/2
Yes, ma'am.
is a rational number, which means then it's a real number.
I got that.
So that means the real and rational, it's going to be colored yellow. I'm going to go with this yellow. It's a little bright. Well, I don't know. Does that, everybody see that? So it's real and it's rational, but it's not an integer or anything like that, because an integer is a positive or negative, like whole number, like 1, 2, 3, -3, -4, -5, 0. It doesn't have anything past the decimal point.
Okay.
All right. 4.25. That is a real and rational number because it is a terminating decimal. Like 4.25 terminates, it ends after 0.25. So a terminating or repeating decimal is what a rational number is. So it's rational. Is everything that graduates out from that. So let's take -21. -21 and it's a real number. So real, rational, and integer is colored purple. So -21 would be colored purple. Now, the square root of 4, I need to take it to its lowest form, which is going to be, what is the square root of 4? It's 2. Well, 2 is a whole number. It's an integer, so it's rational and real. Because once you start inside that smaller subset of numbers, like whole numbers, then you know it's an integer, you know it's a rational number, and you know it's a real number. So real, rational, integer, and a whole number needs to be, it's actually also a natural number for these particular purposes. The only thing that wouldn't be a natural number in here is 0. Okay, so this one's going to be colored green.
Courtney just joined.
I'm sorry?
Courtney just joined.
Oh, okay, good. Hey,
What's
Courtney.
it? Hi, what's a natural number?
A natural number is all the numbers that we use to count, like 1, 2, 3, 4, 5, 6, 7. It's but does not include 0. 0 all of a sudden makes the difference between whole numbers and natural numbers. 0 is the only difference. So a natural number is going to be the number 5. Another natural number on here is going to be 18. Another natural number is going to be 43. Is that a 43? It is, or whatever that was. Oh. Anybody else see any other natural? Oh, 99. I'm trying to see if I see any others. Oh, the square root of 100. I'm sorry?
And they can't be negative?
No, they cannot be negative. That would make it an integer.
Okay.
So good question. Because you want it to be, it just is those numbers that we've probably been using since kindergarten. The fact it's just everything that we've ever used to really count. And then whole numbers, the only difference between the set of whole numbers and natural numbers is the number 0. And then the difference between whole numbers and integers is now you've included negative whole numbers.
What about 11 over 1?
11 over 1 would actually be good one. That one would reduce to 11. So that's also going to be a natural number, which is then a whole number, which is then an integer and rational and real. Anybody else see one? Oh, the square root of 36 is 6. So that's a natural number, a whole number, an integer, rational, and real. Anything else? Anybody see one I'm missing? Okay. So the next one, let's take a look at the square root of 11. That's going to be a number that repeats on forever and ever and ever. I think it's 3 point something, and it goes on and on and on and on. It doesn't repeat, but the numbers go on. Like it's the answer is 3.3166247 and goes on and never the pattern. It's not a pattern. So it's not a repeating or terminating decimal. So that would make it irrational. So real and irrational is supposed to be orange. I don't have an orange color on mine, so I use red. Sorry about that. So that one is all right. So lots of feedback. Yuck. Okay. The next one, negative 2.1111. So that's a repeating decimal, and a repeating decimal is rational. Okay. Everybody understand that? So that one would be colored yellow. And then 2 3/8. 3, so what you would do, 3 divided by 8, to find out what the decimal part of that one is, it's 0.375. So it's a terminating decimal. So it's real and rational. 0.125 is a terminating decimal. So it's real and rational. Negative 8.07 is real and rational because it is a terminating decimal. 0.33333 is real and rational. 5 3/4 is real and rational. Oh, but what about 24 over 6? What does that reduce to? Anybody know? Okay. 24 divided by 6 is 4. So that's going to be real, rational, an integer, a whole number, and a natural number. So that one's going to be painted green.
So would negative 3.5 also be yellow?
I'm sorry? Yes.
So with negative 3. Okay.
Perfect. Good job. And 7/8 would be yellow. And negative 8.9 would be yellow. And negative 4 2/3 would be yellow. Negative 47 is real, rational, and an integer. The opposite of the square root of 9. The square root of 9 is 3, and the opposite of 3 is negative 3. So that's an integer. So thereby it's real and rational as well. One-fourth is real and rational. Now, the square root of 8 is not real or rational. It is irrational. Pi is irrational. And negative 5 pi is irrational. Does that help you guys?
Yes, ma'am. Thank you.
Oh, not a problem. Are you understanding it a little bit better?
Yes, ma'am.
Oh, good. How about everybody else?
Yes, ma'am.
Yes, I did think there was a suspicious amount of yellow shapes. So I think they were trying to, Samantha asked that question. Yes, there seemed to be an abundance of that. So, so I think they wanted you to really get that point. Let's see. I'm trying to think. Do you want me to go on and start working on the classifying one? Not classifying, I'm sorry, ordering. Does anybody need help with that one?
I got that one.
Okay, everybody good on that one?
Yeah.
All right. Are there any other questions?
I had questions on our guided practice problems.
Okay.
It was number 7 and 8.
All right.
91 and no, from page 92.
It was page 92?
Yes.
We were doing two-step today, right?
Yes, ma'am. I like 2 steps.
Yes, me too.
Because, like, 1 step, it's like you're not really doing anything, but 2 steps, you're actually, like, getting something done.
Yeah, I know. You feel a little more accomplished. Sophia, were you asking about 7 and 8?
Yes.
Is that what you're, okay. The output of a function is 5 more than negative 2 times the input. Find the input when the output is 11. I can't understand any reason why that would be confusing at all, Sophia. I'm just kidding. That is a crazy worded question. Let's see. I'm going to try to find a blank. Oh, the feedback is killer.
I know, it's so annoying.
So annoying.
Echo.
I'm gonna ask Landon how I can fix that.
Echo.
Rude.
It is so bad.
Is it now? Oh, yeah.
Please let it be blank. Sometimes I open these blank PDFs and they're not really blank. Okay, so 5 more. I got to write my numbers down. Oh, man.
Am I the only 8th grade?
Am I the only 8th grade?
Yeah.
I don't know. I don't think so. We
Okay,
have,
good. I'm feeling kind of lonely.
yeah, there's a couple.
That's my dog, by the way, if you can hear.
Oh, normally you can hear my dog, so.
My dog has like the most loud, annoying bark ever.
My little dog does. My little favorite dog, to be perfectly honest, has a
Does he
very
have like a little yippee bark?
yeah, it's not real yippy, but I don't know. So he can be a little annoying, but the greyhound, for whatever reason, and only in math lab, he gets really whiny in math lab. I'm like, what are you doing? Okay, so let's talk about input and output. Input is always the what? Did y'all remember this? Which variable is input?
It's on the left side.
Yes, and the variable that you normally use for input is what?
X.
X. Good job. Y'all are geniuses. Don't even need me.
God, please don't jump out of the chair.
So the output of a function, so the y of the function is 5 more than 2 times the input, negative 2 times the input. So that would look like, oh, there, something did come up. Summation. Don't let that frighten you. Though there's my greyhound whining. Y equals. So the negative 2 times, but 5 more than that.
All right.
Shh, be quiet. Quit whining. The students don't want to hear you whine. All right, and then does that make sense now?
Yes.
Okay, good. And then to solve it, you would then find the input when the output is 11. I was like, okay, give me a number. Here we go. So then you would plug in your 11 and you would subtract 5 from both sides. And then divide both sides. Does it bother y'all when the variable's on the right?
Not really.
Eh.
Yeah, I probably should have written it the other way, but.
Oh, dog, no. Oh, crap. No. Crud. Crud. Dog, why do you do this?
So if you get it to this point, you could then just write that. But the other way that you could have written this at the very beginning is to then do negative 2x. If you don't like to have your variable on the right, you could have written it like this. And then solved, and it would have.
Okay.
I have a question, like, for the second one, number 8. Because it was like, it gave me like a decimal, and I just put it as a fraction at the end, but to make it easier, but I don't know if I did it wrong or something.
No, the answer is actually a fraction. It's 1 3/4. Is that what you got?
Yes.
Yay, you got it right. I can work it out though. The output of a function is 4 less than 4 times the input. Find the input when the output is 3. So we can definitely work it out. But good job. Y'all are doing great. Because these were definitely the hardest of the guided practice problems for sure.
Mm-hmm. All right, I'm going to go finish my science work. Thank you, Ms. Sparks.
Oh, not a problem. Take care.
All right, you too.
The output of a function, so I'm going to just do it this way, is 4 less than 4 times.
What
so
number is
4x minus 4 equals y. And then they want to know what the input is if the output is 3. So you're going to add 4 to both sides. And then divide both sides by 4. Which gives you 7 over 4. And you can leave it that way if you would like, or you can change it to this. I don't care.
what? Wait.
Because 7 over 4 equals 1 3/4.
But if you're dividing both sides by 4,
This
why would it be like
cancels.
7 divided by 4 equals like this long number?
7 divided by 4 should be this in decimal form.
Okay.
Because if you plug in 7 divided by 4, like you when you plug that into a calculator, you plug it in exactly as it appears. So it's 7 and then divided by 4, and you should get 1.75 because 3/4 equivalent decimal is 0.75.
Okay.
Good questions.
And then on the page 88, I did not get number 49. I didn't get how to do it.
Page 88. Okay, 49. The rectangle or triangle has an area A. Write and solve the equation to find the value of x. So for that one, you would have to remember what the formula for the area of a rectangle is. But that's base times height.
Okay.
Okay, so 12 inches times x. So 12x equals 54. I'm sorry, my dog is growling. It's somebody walking by the house. I don't know if y'all can hear that or not. I apologize.
So would you just get 4.5 inches squared?
Well, technically, this is 12 inches times x inches equals 54 inches squared. So let's take that. So we have 12x inches squared equals 54 inches squared. My writing is awful. So when I divide both sides by 12, what did you get?
4.5.
Which is correct. But I actually can take the inches squared off also. So they cancel out. So you would get x equals 4.5.
Okay. 4.5
Inches. Yeah. And so do you remember the formula for the area of a triangle? Is it's 1/2 times base times height?
I don't
Or
remember.
did I just put to 49?
I haven't done 50 either.
Okay, the formula for that one is 1/2 times base times height. So what was it? I have to toggle between the two of them. 54, so 72 centimeters. So 72 centimeters equals 1/2. And then the base was 16 and the height was X, right?
Yes.
So 72 centimeters squared equals 1/2 times 16 is going to be 8x. Then divide both sides by 8. And so that answer is going to be 9.
Okay.
So the height is 9.
Okay, that makes more sense.
Yeah, it's one of those things where you have to remember those formulas, and I don't think y'all have probably even talked about those since you and I were in 7th grade together.
Yeah.
In class. So you probably haven't seen that in a while. So you have to be reminded of those. But I try to do a few of those because obviously next year in geometry, y'all are going to have those. So I try to dust off those cobwebs for you and remind you of them every now and then in the homework. But we can always go over them.
Okay.
Great questions, though. Any other questions?
Can you do some on the ordering numbers?
Absolutely, I can. Let me pull that up. Okay, so ordering real numbers. So what you want to do is in each of the rows, you're going to circle the set of real numbers that are listed from least to greatest, and then you'll color the design in the bottom according to that. So in that first row, this one's fairly easy in the fact that there's only 3 numbers, and we know that -2 is the smallest of all those numbers on the number line, right? And then 0, and then 1/2. So it's going to be that one. So anywhere there's a number 1, you would color yellow. I don't see another number 1. So then on the second line, you've got -1, 1/10, and 1.4. So that being said, let me see if I can split my screen. And tell me what happens when I split my screen, you guys. Can you still see everything okay? Can you see both screens okay?
Yes, ma'am.
Yes, ma'am.
Okay. Can you see the blank one? Or not at all? Like, can you see where I'm writing right now?
No, ma'am.
No, ma'am.
Okay. All right. Then I'm going to have to probably, I'm going to try to write some of these numbers down and then toggle back and forth because there's not enough room on that worksheet for me to write. That's why I was telling you guys you might need a separate sheet of paper to work those out. What you want to do anytime that you're ordering numbers, what is the very first thing that you guys want to do? Anybody tell me? What form do they need to be in order for us to realize what is biggest?
Decimal form?
Yes, perfect. Good job. That's it exactly. So, here they are. So the only one that's not in decimal form here is the 1/10. How do I put that in decimal form? I can either go to the calculator and put 1 divided by 10, or I happen to know that one pretty easy, and it is in decimal form 0.1. Yes. So to put these in order, -1 is the smallest. 0.1, that's a pretty 0.1. Or 1/10 is the next one. Oh, it's just not writing well. 1/10 or 0.10, and then 1, and then 4. So which one is that? Oh, that's 1.4, isn't it? Okay, so which is bigger, 1.4 or 0.1?
1.4.
Yes, that's bigger. So that 1/10 is going to go in the middle. So it's going to be net. We're looking for the one that says -1, 1/10, and 1.4. And that's this purple one right here. This is purple. That first one. So wherever there's a 2, or any 2s, they're going to be colored purple. Like that. So now the third row, you've got -4, -5, and the square root of 3. Well, the square root of 3 turned to a decimal is 1 point something. So -5 is the smallest number in this row. So -5, -4, and the square root of 3. That's from least to greatest. Would you all agree? So wherever there's a 3, you're going to color it yellow. There's going to be a lot of yellow on this one too. All right. Does that make sense?
Yes, ma'am.
Is that making it, okay, is this making it a little easier? All right, the next one, our numbers are 1/4, 0.5, and -1 1/8. Well, there's only one negative number, and we know it's going to be the smallest. So it would be, we would start there. But what is 1/4 expressed as a decimal? What does it look like?
0.25.
0.25, is that what you said?
Yes, ma'am.
That is it, exactly. So which is smaller, 0.25 or 0.5? Does it help to see them written out? Oops.
Yes,
0.25.
0.25 is smaller. It's kind of like thinking, is a quarter bigger or is 50 cents bigger?
Okay.
So, A quarter is definitely bigger. So on that one, the way they would be ordered is -1 1/8, then 1/4, and then 0.5. So that one's going to be green because that is expressed in the right order on that number. So anywhere there's a number 4, you're going to color it green. Like that. All right, the next row. We have a couple negative numbers. So those will be the ones that are going to be from least to greatest. That would go first. So that's going to be -2.4 and then -1.7 because when it's a negative, right here, is it -2.4? -2.4. And then the next smallest is -1.7. And then the next smallest is obviously going to be what? 0. And then the next one's going to be 1/3. So where would which one is that?
Blue.
Good job. So anywhere there's the number 5, you'll color it blue. Okay. So now number 6. The good news about this one, it's a lot of fractions, but the great news is that they all have the same denominator. That's yay. So we don't have to worry about getting a common denominator or actually turning it to a decimal since they all have the same denominator. So what we want to do is look for, because there's some negatives, we want to look for the one with the largest numerator that's negative, and that would be the least. Does that make sense?
Yes, ma'am.
So the largest negative numerator is what?
5/8.
-5. Yes, perfect. Good job. -5/8. And then the next one is?
-3/8.
Yes, sir. And then we start into our positive. Is 1/8 bigger or smaller than 7/8?
Smaller.
Okay, so the order is -5/8, -3/8, 1/8, and 7/8. So that one's going to be yellow again. They really do like yellow on this sheet. So anywhere there's a 6, it's going to be colored yellow as well. All right. Now the next one, we've got a couple of negative numbers. So we want to determine which one is bigger there. So which one is the biggest negative number? Or this, I guess, yeah, the least of the, you know, like it would appear to be the biggest because it looks like it has, quote unquote, the biggest absolute value. So what would be smaller? Like if you were in debt 4.5, or if you were in debt one and 1/4. If you owe your mom and dad $4.50, or you owe your mom and dad $1.25, which way do you owe more?
4.25.
Yeah, yeah, right there. It's 4.5, and I may have said it wrong the first time, but it's 4.5. That's going to be the least number, and then -1.25, and then the next smallest. What is smaller between 1/4 and 3.5?
1/4.
Right. So the one that's in the correct order here is blue. Right here. So anywhere there's a 7, you'll color it blue. All right. For number 8, this one we actually might have to turn those into, so we've got quite a few negative numbers, so we're going to have to turn all of these into decimals. So we got to look up what is the square root of 8. It's 2.828. So we've got negative 2.828. Is that what you got also? Or did you do it?
Yes, ma'am.
Yeah. Okay, so we got negative 2 point, and then negative 1 3/4 looks like this. And then we're going to do 7 divided by 12. And that turns out to be negative 0.583333, repeating. And then we have negative 0.33. So we need to put those in order. I think we kind of just did. Didn't even do that on purpose. But so this number here is the least. Would you agree? Because with negative numbers, the bigger the number looks, the deeper you're going into debt. So the farther it is to the left on a number line. So these are actually all in order. So the first one that we used to try and figure out what our decimals were, which is the purple, this is the correct answer. Does that make sense?
Yes,
You understand that you kind of have to take it to the decimal first and then line them up. Like some of them we were kind of blessed in the fact that we had 2 negative numbers and 2 positive numbers, so you could kind of narrow that down and make the comparison. But when you have ones that are like that, you might have to actually take them all to the decimal form first and then do it. So wherever there's a number 8, it gets colored purple. All right, so number 9. We only have, there's 2 negative numbers, and one is negative 0.5, and the other is the square root of 1, the negative square root of 1. And the square root of 1 is 1, and the opposite of that is 1. And so then we have 1, and then we have 1/2 or 0.5. And then we also have 0. Did I get every number? 1, 2, 3, 4, 5. Yeah. All right. So what's the smallest number in this list?
-1.
Yes, sir. So the negative square root of 1 is the first one that you would write down. So negative square root of 1. And then the next smallest is what? Negative 0.5. And then the next smallest is 0. And the next is 1/2 or 0.5. And then the next is 1. So which one of those is right? I think it's green for that one. Is that the right order?
Hello.
Hello? So for 9, you would do that. Color that. Yes?
I have a question. It's not the guided practice problems.
Okay. Let me just finish this last one here, and then we'll go back to the guided practice. Okay?
Okay.
All right. And then number 10. Eli, is this helping?
Yes, ma'am.
Okay, good. Do you understand it better?
Yes, ma'am.
Oh, good. Okay, so on this one, we don't have any negative numbers. We just have to go through and classify each individual one. So 4 divided by 9. 4 divided by 9 is 0.44444 repeating. And then we have pi, which is 3.1415. And then we have 2 1/3, which looks like 2, and then repeating decimals. And then the square root of 2 is 4142. And then the square root of 4 is 2. So of these, which one is the smallest? That's a point. Which one is smallest? Do you know?
$1.444.
It's close, but this is actually a decimal right here. So it's 4.444 is the smallest. So the 4/9. I don't know if you could tell that was a decimal. Can you even see that? Maybe it's not on the screen quite right.
Yes, ma'am.
Okay. So 0.444. And so 4/9 is going to be the first one. And then, so that's first. And then your 1.44414, which was actually the square root of 2. That goes next. And then 2 1/3 would be next. And then pi, no. And then the square root of 4. And then pi. Oh, I forgot about this one down here. So we've got 4/9, square root of 2, the square root of 4, 2 1/3, and pi. So it's this one. So that center one would be colored red. Does that help?
Yes, ma'am.
Okay. Good. All right, guided practice problems. How can I help you? Who needed help with?
Sorry, that was me.
Okay.
I was just wondering how to get to them. I can do them, but are they on our online textbook or?
Yes, sir. They are.
Okay,
You can use your regular textbook, or you can go to the online textbook, and I'll show you where they are. It was 2.3, right?
Yes, ma'am. It was on I went to my regular textbook, and on page 91, it wasn't the.
There were no guided practice problems down here?
No, ma'am.
They look like that at the very bottom. There's like an example, and then there's guided practice 1 through 3. Okay. So it should look like that, but it didn't look like that?
No, ma'am. Thank you. I can find it now.
Okay, no problem. Anything else?
That would be it.
Okay. How about you, Eli? Anything else?
I think I'm good.
Okay.
And this is due on test day, right?
Yes, sir.
Okay. And the guided practice?
The guided practice is really not due on test day. That's just kind of what I like to do, is assign that so that y'all have an idea if you're really grasping what I'm trying to find, if y'all are really understanding how to do the video stuff. It's a way for you to test and see how well did I do on the video. or what questions do I need to ask in class tomorrow? It's
Yeah.
really more of that. So what I would like for you to do is in your video notebook is try the guided practice so that it corresponds with the video. So, because a lot of times you can watch a video, it's kind of like I watched a video on how to take apart my vacuum. But if I wouldn't have taken apart the vacuum and I would have just watched the video, I wouldn't have known for sure that I knew how to do it unless I would. So I would kind of watch the video and pause it and go take apart a piece of the vacuum and then go back. So what you're doing, what the guided practice problems is a way for you to try and apply what you just saw on the video. But as far as what is due, I will put this assignment sheet on there. And that is what is going to be due on, which, can you see that now in front of you?
Yes, ma'am.
Okay, I'm going to be putting that on Google Classroom, and hopefully that will help you keep track of everything that's going to be due.
Yes, ma'am.
So, because there's a lot of things, and I'm not trying to just give busy work, but a lot of times if students aren't at least trying a couple of problems that go with the video, it's hard for them to know what questions to ask. You almost have to try something and go like, I don't get how they do this particular part. You kind of have to try something in order to know for sure whether you know how to do it. And so that's so that when you come to class and you're with me on that day, because we have math lab, which is great, but you don't necessarily have me teaching the beginning of that concept. So I'm kind of the backup on it. And I want to make sure that you all have something to try. So I'll be posting, like I say, I'll be posting this on Google Classroom so that you guys can kind of keep up with it as you go and make sure that you've got all of those.
Okay, thank you.
Have a blessed day.
You too. Bye.
Bye.